Hey guys, this is Mr. Sal. We're going to go through a quick lesson on graphing linear inequalities in this case. Thanks for watching. Don't forget to like and subscribe and comment about the lesson below. Unfortunately, since we haven't learned slope yet, now some of you guys know how to use slope, and that's okay. Graphing the y-intercept and then using the slope may not be an option for some of us, but for those of you that know, that's okay. Just keep in mind that the lines we've been using on the last section were all solid lines, okay? That's because they were equalities, which means all the points on that line give us a true statement. In this case, we still use solid lines, but only where it shows that it's part equality, which again would mean that the values on the line give us a true statement. However, if it does not have the equal part to this thing, then it's either less than or greater than only, which means those values on the line would not be a true statement, and so we have to use a dotted line for that. It's very similar to the number lines we were using before, where maybe used an open circle that goes to the left or the right, whatever, okay? The open circle now is being replaced with the dotted line on these graphs because they're now x and y two-dimensional. We'll choose a point on either side of that line after we graph it with this dotted or solid line, and we have to test for truthfulness or falsefulness. Now there are some points to choose which are better than others, but it doesn't really matter what we choose. It just cannot be on the line, okay? If we find that the point that we chose gives us a false statement, then we have to shade the other side of the line. If it gives us a true statement, then we do shade that side of the line. That doesn't make a lot of sense right now. Let me demonstrate. So if I had my axis right here, let's say that this red line, what the heck, we can even say that it was greater than or equal to. So it's a dotted line, right? Well, if I tested a point on the left of that, or in this area, let's say I tested this point, and I found that it was, you guys want it false or true? True. If it were true, then I would shade towards that side of the line. What this means is that any point in that shaded region would give us a true statement in the original inequality. So if you wanted to, you could you could test another point in here like this one, and just to see if it actually is true, which it should be if if we've done that right. So this is the step that we would be doing at the end there for testing, okay? So they give us this point at 8, -5. Sorry, I should have used the pen on that one. 8, -5. So we got to determine which of these would be a true statement. Oh, you guys may notice they're all the same, right? It's just the only thing that's changing is the inequality on these. I've got less than, greater than, less than or equal to, or greater than or equal to. But again, if it were true, then we would shade on either side of the line wherever that point is. So let's try it. -5x, but x is 8, plus 2y. So plus 2, and the y value is -5. And we're comparing this to -4. Right now we're looking to see if it's greater than. So let's multiply this out and see what we get. -5 times 8 is -40. Plus 2 times -5 is -10. Is this greater than -4? Sorry, that's plus. -40 plus -10 is -50. Which is greater than -4? Sorry, I should have put a question mark there. That is false. This one is false. So if this were the case, then I would be shading the other side of the line from this test point. Now we can assume that this would also give us the same value on this one. So this one just changes to be -50 is less than -4. Yes, that is true. What about the next one? Well, that would be -50 is greater than or equal to -4. Still false. And then the last one, negative 50 is less than or equal to negative 4. Well, while negative 50 is not equal to negative 4, it is less than, so this one is true. So here we go. We need to graph this thing, which means we also need a table to work with. Now, just like we did in the last section, we still only need 3 points to graph in order to make the line. On the computers, on the homework, you'll only need 2 points, of course. But for now, we're just going to look at 3 points because we're doing it by hand. So let's look at the equation. All right, well, I'm going to start with an x value that is 0, so the y-intercept. So I'm going to replace the x with 0 and see what happens. I apologize, I put the inequality right there. I'm not so worried about the inequality in this one because this is where the line is going to be. So we can just treat this as an equation and not worry about if we need to flip the sign or anything, okay? So I got y is equal to 7. I'm going to make that a phantom 0, and I've just got y is 7. So I have the point 0, 7, which would be up here. There it is. Next up, I am going to choose an x value that is negative 1. I'm choosing negative 1. You could have chosen 1. However, that point is going to be off this graph, which doesn't really help us very much. So, I am choosing negative 1. So this is our new equation. We'll go ahead and solve it. And there we go. I got a y value that's 0. So I have a point at negative 1, 0, right there. Next up, I'm going to choose an x value that is negative 2. And we'll go through and solve this one as well. So now that we have that, y is negative 7. We can graph that point as well. Negative 2, negative 7. Right there. And now I'm ready to graph that thing. That'll do. Yep. I got that red point. It's pretty close. I mean, I made it big enough. It's touching the line. Well, this would be really nice if this were an equation, because it would be done. Now, this one is a solid line, though, because it is part equal to, okay? But we are not finished. We have to choose a test point to test, okay? The question then becomes, what point do we test? Now, you could choose any point you want, as long as it's not on the line. However, there are some points that are easier to test than others. Specifically, if we can, 0, 0. Now this one's really close to the line, but it is not on the line. So I am going to test this point. Test 0, 0 in the original inequality, which was, so I'm going to go into that inequality and replace x and y with 0. And this, again, makes this extremely convenient, because anything multiplied by 0 is 0. So I got 0 plus 0 is less than or equal to positive 7. So 0 plus 0 is 0. 0 is less than or equal to 7. This is true. So I know that the point that I tested was true. And that means that I am ready to shade on that side of the line, which in this case I would say is the right. I mean, you could choose which way you want to say it, but whatever. I did it like this. Some of you guys, I don't know, I have had students bring markers or highlighters and then they kind of fill in the whole thing. Some people make it look like a unicorn, whatever. Whatever makes you feel like it is pretty is good. Well, we're going to graph this one, so we will make a table. And this one is in standard form, so I'm going to choose, if I can, the intercepts for this thing. So let's look at the original inequality. But again, I'm going to treat it as an equation because the line is going to give us where it's equal to. This one, however, is only greater than. So I know I'm going to be using a dashed line for this one. So again, I'm not treating this right now as an inequality, but an equality. So I'm going to choose an x value that's 0. and replace x with 0, which makes this 0 plus 12y equals 24. But once again, we don't really need to show the 0 right there. So this makes it nice to solve. I'm going to divide both sides by 12. And I got y is 2. So when x is 0, y is 2. That gives me this point. Next up, I'm going to choose a y value that's 0, which will give me an x-intercept. So again, I rewrite the equation here. And we'll go through and solve this thing. So I've got that x value now, -4, which gives me this point right there. Now the next value we choose, again this can be a little tricky. Next point we choose could be a little tricky depending on which one we choose. In this case, I am going to choose, I'm going to choose a y value for this one, okay? Specifically because, well, 12 is bigger than 6 and it's a multiple of 6. So if I choose a y value for this, then it should give me a pretty whole value for, or an integer value for the x, which is going to make that easier to graph. Now if it's not, again I have the pattern, it should just confirm the pattern from this. So if it were fractional, that's okay. Well, what value am I going to choose? Let's say y is 1 and see what happens, okay? So we'll finish this part. So x is -2 when y is 1. -2, 1. Again, that confirms the pattern on this thing. So next thing, we need to draw the line for this thing. So what have we got? Something like this right here. All right. Now this one, this line that we've drawn is solid. However, the inequality does not have an equal part to it, so we need to make this a dashed line, which I will do now. There we go. But that is not all. We need to test one of the points. And again, just to keep it simple, I'm going to test the point 0, 0 right here. All right, so let's look at that in the inequality. And we'll see if this is a true statement. This is false. Now, since this one is false, all other points in this region or interval, or however you want to say it, would be false. Okay, so once again, that means if I tried even this point right here, it would have given us a false statement. Which means that if I tried a point up in this area, like this one, that one would have given us a true statement, which means that I should be ready now to shade that area. There we go. That's pretty good. Here's another graph, but the form is different. So, but they want us to do this with the table again, because we haven't learned anything about slope yet. So let's make our table. 3 points for x and y coordinates. Now since this one is in this form, I'm going to choose an x value that is 0, which would make this pretty easy. So in this, again, and we're going to make it an equation, y equals 7x, but x is 0, and then we'll subtract 4. So solving this thing, so we have this point at 0, -4, 0, -4. All right. Now we could choose a y value for this. However, again, if we just continue to choose x values, we'll have the y value pretty directly. So the next one I'm going to choose is x is 1. All right, so let's work this one out. So we have the point at 1, 3, right there. And we could continue on this pattern and just see what happens when x is 2. Let's go and see what does happen. So we'll work this one out also. And we'll graph this point now at 2, 10. Right up here. And we're ready now to graph this line. Bam. Okay, well, some of you guys noticed this one does not have an equal part to it, so we do need to make this dashed line. There we go. So it's time to test at some point. And I can see right here that the line is not going through that point, even though mine is kind of curved into it. The point 0, 0. So I am going to test this point. So we'll put it into the equation. The inequality. So again, I've just replaced the x and y value with 0. Let's see what happens. And this is a true statement. Since this is true, the test point, which was, I'll say that's on the left side of that line, we can go ahead and shade on the left side of that line right there. All this stuff. So some of you guys are worried, with all the shading and stuff. I'm using pretty colors, which not everyone has when it comes time for the test. So we'll do this one all in black ink so that we can see what it may look like if we were to do it in pencil or ink. We still need the table on this thing though. So we got the table right here. For this inequality, again, we're going to start off by treating it as an equality. I'm going to start by choosing an x value of 0. And we'll solve this. So that gives us this point at -1, 0, -1, which is right here. So again, I got that point right there on my graph. Next up, I'll choose another value of x. Let's say 1 in this case. So the equality would look like this. And we'll solve this thing. So the corresponding y value is 2. And we have the point at 1, 2. Alright, next up, I'm going to choose actually an x value that's -1. You could have chosen positive 2, which would work also. Let's put this into the equation, and we'll solve this thing out. So I have this point at -1, -4, which is right there. So we'll draw the line on this thing. Something like that. I did miss the line again, so I'll just make that point a little bit bigger. Yeah, it's touching it. That's good. Okay. This one does need to be dashed, so you'd have to take your eraser now and kind of put some dashes in there. Or if you wanted to go back and just make it a dashed line. Some people do dotted lines for these with the pencil or the pen, and that's okay also. It means the same thing. Well, we need a test point though, and I can see that this line is not going through the origin, so I should be able to test 0, 0. So let's see what that looks like in the inequality, and let's see if this gives us a true statement. So it's showing there that 0 is greater than -1, which is true. So our test point is true. So to shade this, if I had just a pencil or a pen or whatever, some people like to just put lines out like this, which works. Alright? Some people get all crazy and they make it cross-hatched. I don't know if that's like an artsy thing or what, but it looks pretty. For just having one color. Alright, we've seen these types before, and we could make a table for this. It's not going to be too bad. Because we really only have one variable in this case. It says that x, on the line, it would be x equals 7. So if I said y was 0, then x would be 7. But if I said y was 10, x would be 7. But if I said y was -10, x would be 7. So that gives us these points. 7, 0, right here. Also 7, 10. And 7, -10. There at the bottom. Oh, what does this do for us? So we can draw this line. That looks pretty good. However, again, this one does not have an equal part to it. So we're going to have to make this, it's not as good, but dashed or dotted, whatever you want. But we do need to test a point. We will test 0, 0 right here. The thing about this 0, 0 point that I'm testing is that there's no y value to replace in the equation, which means that y value doesn't really matter. I'm just testing the x value. So I'm going to replace the x with 0. Is 0 less than 7? Well, we don't need to go any further than that to see that it's true. So I can start shading in that side of the line right there. Again, you can just do the lines or cross hatch it, whatever's good. Whatever makes you feel good inside. Alright, what about y is greater than or equal to negative 6? Once again, we'll make a table for this thing. Once again, we could look at this as the equation, y equals negative 6, which means we don't really have an x value to replace. So if I said x was 0, then you'd get a y value that's negative 6. If x were negative 5, y is negative 6. But if x were positive 5, y is 6, negative 6. So we can put these points in. 0, negative 6. Oh, whoops, that's the wrong direction. There we go. And negative 5, negative 6. 5, negative 6. And we get this line going straight across. This one does have the equal part to it, so I'm going to keep this a solid line. Next we'll test the point 0, 0. Now again, in this inequality, I only have a y value to replace. So I got y is greater than or equal to negative 6. But I've replaced the y with 0. This is a true statement. So I will be shading, I guess above that line right there. There we go.